The good news with this one is you don't need a worksheet. The bad news is you have to use your own paper. So this lesson's on multiplying polynomials. So we just did multiplying monomials by monomials, and now we're going to be multiplying two polynomials by each other. There are a variety of methods for doing this. We're going to go through all of them by the end of this course. Let's just start with some examples. The directions are simplify or multiply. No equal sign here yet. Number 1, we're just going to take something like x plus 4 times x plus 1. Now, I know many of you are thinking of a word, but right now I want you to focus on the distributive property, the same property that we did yesterday with multiplying monomials. Whenever we do the distributive property, we take this thing that's acting like a coefficient and multiply it by the x, and then multiply it by the 1. So when the first one multiplies by the x, then we're going to use the distributive property again and say that's really x times x, which is x times x plus 4, plus 1 times x plus 4. So think about that for just a minute. The x plus 4 multiplies by the x, and the x plus 4 multiplies by the 1. Then we simplify this thing to get x squared plus 4x plus 1x plus 4, and then combine our like terms, x squared plus 5x plus 4. This kind of polynomial is also what we refer to as descending order. In terms of the x's, the exponents are descending. They're getting smaller in terms of their value. Number 2, if I take 2 minus y and I multiply it by 3 plus 5y minus 4y squared. Now, for those of you who wanted to FOIL on the first one, we can't do that here. For those of you who don't know what I'm talking about, don't worry about it. Take the 2 minus y, we're going to multiply it by the 3, then we're going to multiply it by the 5y, then we're going to multiply it by the 4y squared. So we get 3 times 2 minus y plus 5y times 2 minus y, then minus 4y squared times 2 minus y. Multiply in, distribute again, we get 6 minus 3y plus 10y minus 5y squared minus 8y squared, then plus 4y to the third power. Add like terms. We have y's here and we have y squareds here. 6 plus 7y minus 13y squared plus 4y cubed. If we look at this polynomial, this is what we call ascending order. I haven't asked you what order I want it in. For right now, it's good enough to put it into either descending order or ascending order. Just don't mix and match. But we'll practice with that. I'm never going to count off in terms of what order it's in, but there are times where it's going to be really helpful for you to have it in one or the other. Okay, next problem. 2y plus x times xy minus y squared plus 3x squared. Again, we're going to take the leading one and multiply it into each part, giving me xy times 2y plus x minus y squared times 2y plus x, then plus 3x squared times 2y plus x. And we're back. Then you multiply the xy by the 2y to get 2xy squared plus x squared y, then minus 2y cubed minus xy squared plus 3x squared, not 3, 6x squared y, then plus 3x cubed. Then you want to add your like terms. 2xy squared is a like term with, we have a negative xy squared, and that's it. So 2 minus 1, 1, xy squared. We have an x squared y and a 6x squared y. Add those to get 7x squared y. Then negative 2y cubed and a plus 3x cubed. So then let's think about order. If we want to do descending order, we have to pick it either with the y's or the x's. We can't do both. So let's pick the x's and do descending order with the x's. We look for the largest power of x, the 3x cubed. Then we're going to add the 7x squared plus x y squared, and then minus 2y cubed. So if you look at the x's, we were descending order with the x's. And as often happens, we were descending with the x's and we ended up being ascending order with the y's. It's nice symmetry and it looks pretty good. So that's our final. Now we're going to solve. Remember that anytime we solve, we want to express our answers in set notation. That means braces. For number 4, we're going to do x minus 3 times the quantity x plus 7 minus then x plus 1 times x plus 5 equals 0. Big thing about the minus in front of two binomials being multiplied, I'm going to put another set of parentheses around those. You won't see that in your problems, but you should write it in so you don't forget to distribute negatives. Okay, if I multiply these out, we're going to go x minus 3 times x. So I have x times x minus 3, then x minus 3 times 7, minus, then I'm going to do a giant set of parentheses, go x plus 1 times x, so x times x plus 1, plus, and then 5 times x plus 1 equals 0. Continue with the distributive property, x squared minus 3x plus 7x minus 21 minus, still have a giant set of parentheses, x squared plus x plus 5x plus 5 equals 0. Going to combine these like terms to get x squared plus 4x minus 21 minus, then still have a giant set of parentheses because I need to simplify within the parentheses following order of operations, x squared plus 6x plus 5 equals 0. Now we distribute the negative, that's in front of the giant set of parentheses. X squared plus 4x minus 21 minus x squared minus 6x minus 5 equals 0. We haven't done factoring yet, so our x squared terms should drop out. Combine our like terms, negative 4x and positive 4x and negative 6x are negative 2x. Negative 21 minus 5 is negative 26. Add 26 to both sides, we get negative 2x is equal to positive 26. Divide by negative 2, we get x is equal to negative 13. Number 5. Number 5, I'm going to go back temporarily to a simplify because I know many of you are aching to see what you have learned in middle school, that if we square a binomial or multiply a binomial by another binomial, there is another strategy to use other than just using the distributive property. First of all, if I have x plus 2 quantity squared, we can never, ever, 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 ever make that x squared plus 4. That doesn't make sense. That's breaking order of operations. It's distributing an exponent across pluses and minuses, and there is no distributive property of exponents across plus and minus. In fact, there is only one distributive property, and that's multiplication division across plus or minus. So that won't work. But what x plus 2 squared is equal to is x plus 2 times x plus 2. Now, several of you will have learned an acronym named FOIL. FOIL stands for first, outer, inner, and last. And what makes it the best friend of so many of your middle school teachers is that it tends to put the resulting trinomial into descending order, kind of all by itself. It's a good order to make things happen in descending order, and it's also a good way to remember how to multiply two binomials. In fact, I'd venture to say that most of the pre-calculus and calculus students by now just automatically FOIL whenever they multiply two binomials without even thinking about it. So you will get to that point, but for right now, first means we take the first two terms, multiply them together. X times x is x squared. Outer means we take the outer two, which I'm going to do in red here. 2 times x is 2x. Inner means we take the inner two. Another 2 times x plus 2x. And last means we take the last of the 2 and the 2. 2 times 2 is 4. First, outer, inner, last. Combine your like terms and we get x squared plus 4x plus 4. Again, this is not a solve, this is just a simplify. Let's do another simplify. X minus 2 times 3x plus 5. We're going to practice foiling again. X times 3x for first is 3x squared. Outer is x times 5. Inner is negative 2 times 3x. And then the last is negative 10. 3x squared minus x minus 10. It is a lot quicker than using the distributive property, and as we know, quick is good. Number 7, our last simplify. We're going to do x minus 3 cubed. X minus 3 cubed is another one that people are tempted to just say that that's x cubed minus 3 cubed, which is distributing in the wrong way, which is never, ever, 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 ever true. So don't do that. What we have to do is write x minus 3 times itself 3 times. So x minus 3, x minus 3, x minus 3. Then grab your two favorites, join them together by foiling. So I'm going to keep the first x plus 3 out in front, but then I'm going to take these last two and multiply them together. First, outer, inner, and last is positive 9. Then we're going to take x plus 3, multiply it by the x squared. Oh, I almost broke order of operations. Let's combine our negative 3x and negative 3x first. Make it a little bit simpler. X squared minus 6x plus 9. Still with the x plus 3. And now we don't have a choice. There is no foiling when we multiply a binomial times a trinomial. So we're going to take the x plus 3 and multiply it by the x squared, then the 6x, and then the 9. So we have x squared times x minus 3 minus 6x times x minus 3 plus 9 times x minus 3. Giving us x cubed minus 3x squared minus 6x squared plus 18x plus 9x minus 27. Almost there. Combine our like terms. We still have an x cubed, but we now have a negative 9x squared. We have a positive 27x, and then minus 27. So you can see that if we had gone back to the original incorrect answer and said that this was really x cubed minus 27, it can't be because the final one has so many other terms that we'd be missing if we didn't multiply it all out. Let's flip back and do one more solve. Let's say that I have x plus 7 times x minus 2 minus x minus 1 times x minus 3 equals 2. This is kind of like the one we did in number 4. We're going to want to FOIL the first two. I'm going to want to put a giant set of grouping symbols around the second two because there's a negative before those. Foiling the first two, first would be x squared, outer minus 2x, inner plus 7x, and last minus 14. Then I go minus, still have a giant set of parentheses, x squared minus 3x minus x, and plus a 3, and then equals 2. Combine your like terms. We have x squared plus 5x minus 14 minus, combine inside the gray, and we have x squared minus 4x plus 3 equals 2, not 0. Distribute your negative. x squared plus 5x minus 14 minus x squared plus 4x minus 3 equals 2. X squareds drop out. Add the 5 and the 4 to get 9x. Add the negative 14 and negative 3 to get negative 17. Add 17 to both sides. We get 9x is equal to 19. Divide by 9. We get x is equal to 19 over 9. Put in set notation, and you are done. And so am I.